Hi students, welcome back. Today we are going to look at the word break problem on LeetCode. So this is a slightly difficult problem, so follow through carefully. So let's look at the problem statement first. So the problem statement says we are given a string S and dictionary of strings verdict. We have to return true if S can be formed by words in this dictionary. And we can use any a word any number of times. Okay. So let's look at the example. So the given word is string is lead code and the dictionary has lead and code. Then it can be broken here and formed by the words in the dictionary. That is why it is true. So here we have apple, pen, apple in the second example. So dictionary has apple and pen. You can use apple twice and pen once and you can form this string. Here we have cats and dog. So observe that another D is missing here. Okay, we have cats, A and dog. We have cats, dog, but we don't have an. Now, if you split here, we have cat, sand, but we don't have OG. Okay, which is why this is false. Now, let's solve this through an example. Okay, let's say our input string is ABCD. Okay, and our dictionary is A, B, C, and D. Okay, let's say how we can solve this. Let's try to draw the recursive tree. So what we are interested is solving ABCD. So how can we solve this? We can split it at each of these characters and check if the rest of the string is in array. So we can see solve it as f of empty and dictionary contains ABCD or f of A and dictionary contains BCD or f of AB and dictionary contains CD or f of ABC and dictionary contains D. This is CD. Let's write it clearly. Okay, this is CD. So at every point we are splitting. Initially it is empty, f of A, f of B, f of C. And for the rest of the string, we are seeing if it is existing in the dictionary or not. Okay. Here, now if you try to solve this, an empty string can always be formed. This is true. Does ABCD exist in dictionary? False. So true and false is false. Okay. Now, how do you solve f of A? F of A can be split into further subproblems, which is f of empty string. Okay. And dictionary contains A. F of empty string is true. We have already seen that. Okay. And dictionary contains A is true. This is true. Does dictionary contain BCD? False. True and false is false. So this is false. Now, how do we solve f of A? Okay. F of A is nothing but again f of empty string and dictionary contains AB or f of A and dictionary contains B. Okay. F of empty string is true. Dictionary contains AB is false. So this is false. Now f of A we have already solved here. Okay. We are saying f of A is we have solved here. So we can reuse that. This is true. Dictionary contains B is false. This is false. Okay. Both of them are false. So this is false. Okay. Now let's solve f of ABC. Okay. So f of ABC would be f of empty string and dictionary contains ABC or f of A and dictionary contains BC or f of AB and dictionary contains C. Yeah. So it is f of AB and dictionary contains C. Okay. Now we have already said that f of empty is true. Does dictionary contain ABC? No. So this is false. True and false is false. F of A we have solved here. Okay, f of A is true. Does dictionary contain BC? True. True and true is true. Okay. F of AB, f of AB also we solved here. Okay. So f of AB is false. Okay. Dictionary contains C is false. Okay. False and false is false. Here there is one truth value. So f of ABC is true. Dictionary contains D is true. True and true is true. So for f of ABCD, okay, it has one truth value. So this is true. Okay. So this is a recursion tree. So what we have observed is there are so many repeating sub problems and we use the previous solutions. So we can memorize this and use a DP solution. So let's look at how we can memorize this thing. Okay, let's say our string is A, B, C, D, right? Let's say we have a DP array of size n plus 1, which is 0, 1, 2, 3, 4. Okay, at every point in this DP array, we will store the answer for the string from 0 to that. So DP of 0 would be, okay, let's take a better example. DP of 3 would be solution for string 0 to 3. Okay, that means ABC. Okay, if ABC is possible, that's what DP of 3 will have. So at every point, that index represents the function, the solution of the string till that point. So f of 2 will have solution for AB, f of 1 will have solution for A, f of 3 will have solution for ABC. And finally, we will arrive at f of 4, which will be solution for ABCD. So that's how we will store in the DP array. So here if you see, once we found f of A, we used it multiple times. Okay, similarly, once we have f of AB, we used it multiple times. Okay, so we are deriving the future solution based on the past. So how do we? So initially when we start, DP of 0 would be true, right? Then we will slowly build it up. Okay, so our dictionary had A, B, C and D. So let's try to build this. DP of 0 is true. That is our base condition. Okay, what is DP of 1? Okay, DP of 1 would be DP of 0 and dictionary contains A. Okay, DP of 0 is true, dictionary contains A is true, so DP of 1 would be true. Okay, DP of 2 would be DP of 0 and dictionary contains AB, or DP of 1 and dictionary contains B. Okay, DP of 0 is true, dictionary contains AB is false, so this is false. DP of 1 is true and dictionary contains B is false, so this is false. Ultimately, DP of 2 is false. Okay. Now, what is DP of 3? DP of 3 is DP of 0 and dictionary contains ABC, or DP of 1 and dictionary contains BC, or DP of 2 and dictionary contains C. Okay, DP of 0 is true, but dictionary doesn't contain ABC, so this is false. DP of 1 is true and dictionary contains BC, so this is true. DP of 2 is false and dictionary doesn't contain C, this is false. Or of this thing is true. We have at least one truth value, so this becomes true. Okay, so if you closely observe, this thing exactly represents a recursion tree. Okay. Now, what is DP of 4, which is our solution? DP of 4 is DP of 0 and ABCD, or DP of 1 and BCD, or DP of 2 and CD, or DP of 3 and D. Okay, DP of dictionary doesn't contain ABC. This is false. This is false. This is false. dp of 3 is true and dictionary contains d. So this is true. We have at least one truth value. So this is true. Finally, this is our solution. Okay. That is how we build the solution based on the previous values. Okay. So if you just see the recursion tree, there are 2 power n ways in which you can form substrings. So if you write a recursive solution, it would be order of 2 power n and it will time out. The same DP solution we can write in 2 for loops. Okay. Let's try to write that solution. Okay. So first, let's create a set from this list of words so that dictionary contents would be faster. Okay, so we are just forming a set from this dictionary in this line. Next, we will create a Boolean array of size n plus 1. Okay, this will hold our result of the previous iteration. Okay, to start with, our base condition is dp of 0 is true. Okay, then we will start from 1 to length of the string. Okay, and we will solve each of the sub problems in that uh, turn. So what we are saying is, so here this is one iteration 0, 1, 2, 3, and 4. Within the iteration, you have to have the sub problems again from 0 to 3 here, 0 to 2 here, which is I equal to 0 to end. Okay, you have to solve each of these sub problems. That is the other for loop we will have here. Okay, we will go from I equal to 0 to end. So what is our solution? It is if dp of I is true and dictionary contains rest of the string. Rest of the string is this thing. Okay, in that case, dp of end will become true. Otherwise, by default, it is false and it will remain false. Okay, at the end, finally, we will, okay, once we found a truth value, we need not continue further, we can break. Okay, finally, we will have the solution at length of the string. Okay, let's submit this and see. Okay, so what will be the time complexity of this? We have two for loops. This is order of n, and we also have a substring function, which is another order of n. So overall, the time complexity would be order of n cube in this case. Okay, it's not n square. It is easy to miss this substring. It will be n cube. Okay, so now it took 8 milliseconds to run this. Let's see if we can optimize this further. Now, if you look at the given example, okay, so the given string is lead code, okay, and dictionary has lead and code, okay. So the maximum length of the word in the dictionary is max length is 4, okay. Now, when we are looking for a solution, we need not split at 1. I mean, dictionary will not have this string for sure because the maximum length it can have is 4, okay. So similarly, we need not split here because this is not possible. We can directly start from here. Okay. That is because we know that the maximum length of the word in the dictionary is 4. So you need not search for string of size 5, 6, 7, 8 and so on. You can directly say, no, this won't exist. Okay. For anything less than or equal to 4 only, you have to do a dictionary contains check. Okay. So let's add that optimization and see how it will help. So what first thing is we have to find that max length. Like in case of our example, it was 4, right? So for each string in the dictionary, okay, let's calculate max length. Max length would be math.max of max length and word dot length. Okay, now we have the max length. So here at this point, what is the length of the word we are checking? It is n minus I. Okay, so if n minus I is greater than max length, we need not do anything else. Okay, if n minus I is greater than max length, we need not go below and do anything else, which we can assume it's false and continue to the next one. Okay, so let's see how this optimization will help. What is the problem? Length. Okay, let's submit this and see. Okay, so with this optimization, it came down from 8 milliseconds to 2 milliseconds. So these kind of optimizations are also important. Okay, so for this particular problem, it's important to build the recursion tree yourself and uh, observe the repeated subproblems and find the DP solution. Only through practicing the recursion tree yourself, you can build that intuition. This DP tree is exactly same as this recursion tree. Okay, so do practice this multiple times. Thanks for watching. Happy coding.